Hey, pick something up. You don't like the lab?
That was a
Really
ginormous.
large.
Oh my, what are you gonna do with all that space?
Oh, I can fill that. I mean, this is a big classroom.
But it's nowhere near the size of the
Yeah,
other one.
that thing's humongous. How many students do you think would fit in that building?
The whole high school.
Well, we're hoping we have like a class area and a lab area, but it's just that they have, I don't know how to work out. They don't want to have more than 20 kids in the class, no matter what. But, that would be nice to get that many. 21, yeah, that'd be 3, 7, 3. There's fewer sinks they don't have here though.
Really?
Yeah, there's only like, there's a 3, right?
3, I think.
3
yeah.
and then like 1 in like that middle room in between.
We'll get you a little washer tub, you know, like the big
Yeah.
laundry room.
And I had to come up with a proposal for lab furniture with Mr. Taylor. And then when he left, Mr. What was his name?
Inslee?
Bensley, I think Tyler is the name, first name Tyler. He didn't have any of that information, so I had to go through it all over again with him. And then, showing him the lab tables I wanted and all that. And then work with him on getting the fume hood and everything. And then when he left, Mr. Glocker didn't have any of that information. I had to go through it all over again, and then I'm probably not gonna get much of it anyway. For the finances, I don't know. Okay, so open your books. Right here, yeah. I guess let's jump back to 154. So did anybody say differentiability implies continuity? Oh man, I think I put it on my lesson plans as continuity implies differentiability. Nobody's used that yet. You sound so smart. Oh, by the way, would you like a free water container?
Yes, I would.
No. Did you learn that? Yeah, good, Brian.
And like, is it free with the purchase of something else, or is it
Yeah.
like free?
No, it's for free. You don't have to get anything else, but you can get something else. And you can write your own little award stuff on there and show your folks. So we have to know, you gotta know what continuity is. Everybody feel like they're pretty comfortable knowing what continuity is. And then differentiability. Usually in the field, when mathematicians, even scientists are talking about differentiability, it has to do with smoothness. And I remember talking about a student who's someone that worked with GoPro cameras, and they were writing programs to be able to connect the GoPro that somebody was using as they were surfing with a camera on the beach, so that the camera would automatically follow the surfer and that kind of thing. Anyway, it had a lot of calculus in the programming, and you had to have continuity and differentiability to the functions they had in there. I remember talking about it, and it was pretty interesting. And so this is something that's pretty important. And same thing with like building infrastructure for railroad track or roller coaster. You want the path of those to be not just continuous, but smooth. You don't want to have a sharp corner on a roller coaster. Not too sharp anyway, right? Like that. No cuts. Okay, and so what I want you to do, did y'all do the cues yesterday? We started on, anybody get to number 1? Let's talk about, let's do 1 to 11 verbally. Although you can write it in your thing, all you gotta do is put a C, a D, or an N.
I had a question on one of the cues. On
Okay,
the
which
last
one?
one, I didn't know what they were asking.
Yeah. On which one?
Q10.
Q10. Okay, so you look back up at that graph above it, and they're asking for it says f prime at -1 in all of them. And so they're asking, the derivative at -1 is the same thing as the slope at -1. So you go over where x is -1 and go up to that point, and you can tell the slope is negative, right?
Mhm.
And so it's not gonna be A, because A says the slope at -1 is greater than 2. And it's not gonna be B because, or C either, because all A, B, and C means that the slope is between 1 and 2 or 0 and 1, all of those would be positive. And so do you think it's between 0 and -1, or do you think it's between -1 and -2? That's what we all figured, yeah. E. But being able to interpret that kind of notation is pretty valuable, and that's probably what the whole purpose is, to get you used to looking at that, all these symbols, and understanding what it's asking. Okay, look at number 1. See, this says on 1 through 12, state whether the function is continuous, differentiable, both, or neither. Okay, so what about number 1? What do you think? Is it continuous? I see one person nodding. Everybody thinks so, yeah. Is it differentiable? I see one, I see somebody shaking their head. Okay, you notice it does have a cusp, right? And so that means it's not differentiable at the cusp. Okay, where there's a sharp turn, the slope changes instantaneously there. Unless you look at it, I think it's supposed to go all the way up to the cusp. So I would say only continuous. What about number 3? Is it continuous, number 3? No. What about differentiable? No. If it's not continuous, it's certainly not differentiable. Okay, so you would say neither for that one. Number 5? One or the other, or both or neither? Neither, right? Neither. What about 7? You're looking at point C. Okay, yes for what? Both. Good. Everybody see, understand both? Yeah. How about 9? Not continuous, not differentiable. That's C. What about 11? It's like 1 again, right? So it's continuous, but not differentiable. That's C. Okay, good, good. And so now on, I'll let y'all start working on 13 through, what did I say? It was gonna be 27? Yeah, 13 through 27 odd. And on 13 and on, there's an A and a B, but you only have to do the A part. So the A part says sketch a graph of a function that has the indicated features. So answers may vary, but you, like for a 13, you just have to make sure that you're drawing a graph that is differentiable and is continuous at the point 3, 5. So it would probably look something like 12 or 7, okay? But you don't have to write an equation that would do that. Yes.
I have a question on that.
On which one?
20.
Okay. It is differentiable but not continuous.
I thought that was impossible.
It's not possible.
So then why?
Just to see if you remember.
So then what am I supposed to put there?
Not possible.
No.
But that was number 20. But we're doing the odds.
I was just gonna go ahead and do all of them because I found it easier to put all of them in there.
Oh, okay. That's a good point though, because I don't think they have something like that in the odds. But it's impossible to do when it's differentiable but not continuous.
Could you check my work? It won't fit in that.
Four. Like this for 13. So you should have a bunch of different ones, right?
Like all of them.
Oh, it's for 3, 5. So you got differentiable. So that is 13. So in 15, you need to have at 3, 5, the finite limit. So that's equals to 6. Okay, no, okay, so this is. Finite limit equals to 6. So they're not continuous. Yeah. You can continue the line on after this. There's a gap. Yeah, I'm just saying like if you have the line going and then you continue the line after the gap, it would still work. But it's not having it continuing. Well, you might just draw and then, but that's fine. Kind of like this one right here.
There's been,
Yeah, so that's fine. You might want to put on here like this. Right here for 13. Right here. Let me check off. Okay, so this one, it does not have a finite, when you do it, it's not going to finite limit, it has a limit coming from both sides. So you would need to like, maybe come down and go up. That's actually be kind of like, you know, the one here. That's right there. They made it, it turned right down.
Not sure how you will do number 17.
So, you could probably do it something kind of like this. Well, no, that one has a limit. Maybe like this. So there's a function value, but there's no limit because the limit's different on each side. Doing okay, Brian?
I have a question on how to do 35.
35. That's my favorite problem in the whole book. No, actually 31 is. 35. All you have to do is actually take the derivative of each one of those. And the fact that you can take the derivative will imply that it's continuous everywhere. Because like y equals mx plus b, the derivative y prime would be m. So it has no matter where, it's got a derivative, therefore it must be continuous. And you can do power rule to do b and so on.
Thank you.
So you have -2 to 2, and you got to squares. Squares in here. You have to like do 0.7, 0.3, and that kind of thing. Yeah. Okay, so this one you're counting squares, and then the other one, like if you would have -1 and -1. They want to know basically f prime at 1 means what's that slope. And use your pencil. Like if you were to draw a line like this, that has a slope of 1. And if you were to draw a line like this is steep, that's sort of, well, I'm talking -1, -1, and -2. So if we had this up here, a tangent line there, is it between 0 and 1 or between -1 and -2? What's the steepness of it look? It's about like 1, maybe Because here, this says it's between 0 and -1. This says it's between the -1 and the -2. So, you gotta kind of estimate.
Oh,
And most people, when they draw it, you have to draw it in there. Not as steep as this, but a little steeper than that. So like in between. Let me turn this around so it's not too lonely.
did 1 through 11 out loud. Do we have to do that one?
No, you can put DIC did in class or something like that.
Mrs. Belcher,
Yes.
I finished, so do I just like take pictures and send it to you?
Yeah, and if you're planning to come to class Monday, you can just wait and give it to me. But if you're not sure, you can just take pictures and upload it to Google Classroom. Or if you can't do that, you can text it to me or email it.
Okay, yes, ma'am.
And we're just going to move on to 4.7 next, but I don't expect you need to necessarily get into that till tomorrow. I mean, not tomorrow. We're probably going to work on these problems today and tomorrow. I'll see how they do, but you may be way ahead of us. So feel free to work on something else. Here, let me write down the steps. You can write this down. Formula sheet if you want to. That's basically what interpreted. So that one. 30. Okay, so those are the steps. If anybody's interested in writing down, you can. We're doing ones that are like 25, 27, and so on. And if you start working through it and you get stuck at some point, let me know and I'll explain what I mean by it. Well, you say that you'll use the power rule and put 2A that comes to and then, yeah, and then you do that because and then he doesn't have it firms here.
I think there's something in this.
Here would you put, so that's basically the second step that I have written up there. First thing is go ahead and start with these first two and set them equal to each other, or what you can do is just equal to each other. Right? So do the same thing you did here, but with it before you take it with it.
And also, I know it's just a view, that if you're talking about a view,
And so, look, A, you can find A, you already have A, but you can't really find B from that. So if you go up here, you'll get an equation that has A and B in it, and you put A in it.
simplify this, you have to get these C's on one side, right?
You have to get what?
Like, what is C?
Okay, by C, I mean, it's supposed to be differentiable at x equals C, and in this case, it's 1, so 1 is C.
Oh.
Wherever the branches meet, that's the x. Equals C. Okay, so you have a plus b equals 1. Let me just double check. Yeah, okay, so that's good. So you simplified, you're done with step 1. Now you'll get the derivative. Now thinking of a and b as numbers, as constants, take the derivative of both sides and set them equal and do the same thing.
Wouldn't the derivative of A and B just be 0?
If it's by itself, yes.
So like the B would be,
Yeah, so the derivative of b is 0.
except the A would stay the same because you bring it
Right,
down.
because you're gonna put the 2 in front of the a, like you're gonna take the power rule, so it'd be 2a times x minus 2 to the 1 power and then plus 0. That simplifies to 1 equals a plus b, yeah. That was with the original
Yeah,
equation, right, yeah, now you're taking the derivative.
So I got the baby, and then what? A second. What, is there anything to do?
You graphed it, okay, so you're graphing it now. And then, oh, yeah, yeah. Oh, second, delete. And then, and all of that, and right one. Okay. Did you have equity? And if you wanted, you could trace over to the, show the gap, but you can zoom in on it. Make sure it's- You do. Oh, that's sketch numbers. And just a rough sketch.
So A, B, and then another.
What was person? Oh, here's, so you're gonna divide by -2. Yeah. I get in here. Anyway, so there, in fact, it is really function. Pretty much line function. The linear function are all in the straight line. And if you're by term, and you take the derivative of that, which means that we have the derivative every in the derivative. That is all in the function. Okay, so here you just kind of get the derivative, and then here they give you say what the derivative is, and then the derivative is.
When you find what A and the B, what do you do?
What you do, so you go to your calculator and you plug all this in, but for A, you plug in that number, that fraction, and for B, you plug in that fraction, and then you graph it and see if it connects and if it's smooth and how it goes. And then you sketch it. We have weekly things. Go ahead and copy this down.
I got the right A and a B. Go back, my graph never didn't like curve like that. It was more just
Let me see
really.
how you type it in. Oh, so you just did the second print. Okay, and so what you need to do here now is to divide by and then do that Boolean variables where you say X is,
Oh, was it the greater?
yeah, less
Oh,
than,
okay.
yeah, do that stuff. And so do that, and then down here do the other one and do the X cubed, right?
Oh.
Yeah, put them both in. So, yeah, put this one up over here because you're gonna need to take pictures of it. So, this right here is this, and so I guess this dotted line goes with the straight line here, and then you got this green is curving like that. And I'm trying to get the line and the curve to match up, continuous and straight there. So they want to just use the curve from here up to here, and then they just want to use a straight line from there out. Okay, and so this is the curve, and it says the curved left branch of the graph contains origin. Okay, and which kind of tells you that it's got like it has 0, 0. Like put y equals to y, squeeze it into y. And so you know that if you had that 0, 0 is in there, so you get that 0 equals a 0 plus b 0 plus c 0 plus d. And
So you put 0.
yeah, and then you're gonna get all this 0 stuff, and you'll end up with just 0 equals d.
Yeah.
Yeah, and so but that tells you what d is. So you just have to do it by putting the origin in for that. Okay. And then it says it has y prime at 0 equals to 0.2. And so if you take the derivative of this down here and then set it equal to 0 and all the x is equal to 0, you'll find out what another variable is. We'll continue on. Yeah, and then you're done. Yeah, right.
And then you take.
Put a 0 there, and a 0 there, and a 0 there, and then set it all equal to 0. Equals 0. And so see all these canceling, you have to C equals 0. So you find out what C is. And so they continue to give you more information to help you find out what A and B are.
So then you take the.
If they want the second derivative. Yeah. And this is so at this point, you can also put plug in 0.5 for all the x's, like you did 0 here, but put instead of equals 0, you'd put equals 1.
And then you put 1 in.
So you're putting 0.5.
Oh,
Where x is 0.5. Y equals 1. Yeah, like that. And that's gonna help you find out, well, it's gonna, you probably still have A, B, and C in it, but then you have some other instructions. So we'll do some more next time. So y'all are doing that.
Are we doing this next time?
Yeah, we'll finish up tomorrow. They start the next section by the time also. All righty, Brian, I'll talk to you later. You're also dismissed. He just hung up. Okay. And he hung up fast.